So let's talk about Kerberos in this video. Kerberos is one of the implementations of a single sign-on system widely used today. How it works is pretty simple. Basically, you sign on once and then you have access to multiple computing or network resources without authenticating yourself over and over again. So this whole concept could be summarized as authenticate once and use resources repeatedly. And one of the advantages of a single sign-on system is increased security, because a user now needs to manage only one user account and password. He doesn't have to keep track of, or she doesn't have to keep track of multiple or a number of user accounts and passwords to be able to use multiple resources. So the management of user account and password is much easier, and in turn that strengthens security, because there is less chance that you will have to write down your username and password and somehow expose your username and password. Another advantage is also coming from the same reason, because now you have this less number of accounts to manage. From the perspective of an administrator of the system, now you have less accounts and passwords to manage, so that definitely eases administration. However, the disadvantage of this approach is, in case your single sign-on system gets compromised, it may inflict much more damage, because now with one single user account you have access to multiple resources. So instead of only affecting one resource with this single sign-on system, just having one account getting compromised means that you have multiple resources also being affected. So in terms of damage, the amount of damage, it could be much more. That could be the biggest disadvantage of this single sign-on approach. Kerberos was developed by MIT, and it uses symmetric key encryption to encrypt its session keys and tickets. And the encryption method, I said, is based on symmetric key encryption. In particular, it uses this particular algorithm called advanced encryption standard. And in symmetric key encryption, basically you have one key to both encrypt and decrypt plain text. That's why it's called symmetric key encryption, because you use the same key to encrypt and decrypt. Kerberos consists of components such as Kerberos Authentication Server, or KAS, which is responsible for authenticating a subject, and that's why this element of Kerberos Authentication Service called Authentication Service. And then another element, sub-element, called Ticket Granting Service, which is responsible for issuing a service ticket to a subject. And then of course the ticket itself, in this case a ticket that generates a service ticket called ticket granting ticket, is a very important aspect of Kerberos. And finally, they have a service ticket that's used to get access to a resource. Now let's look at how Kerberos actually works. In this diagram you see three elements. One, a subject or a user whose name is Alice, and we have this Kerberos Authentication Server, or KAS, responsible for authenticating Alice. And then we have another element which is actually a network resource to be used by Alice once she gets authenticated. So the whole process begins by Alice sending her username to the Kerberos authentication server, and based on the username, the Kerberos authentication server looks up her password and uses that password to authenticate the subject. Once the authentication part is done, KAS, or Kerberos authentication server, sends a ticket granting ticket and a session key. Both the ticket granting ticket and the session key are encrypted. However, the session key is encrypted using the symmetric key encryption method with an encryption key, which is the password Alice provided. One thing to note here is the ticket granting ticket is also encrypted, but Alice doesn't really have a decryption key to decrypt the ticket granting ticket, so Alice doesn't really have access the content of the ticket granting ticket. Now we're ready for part 2. So now the second half of Kerberos operation is shown here, and we still have the same elements at work, but this time, since Alice got her ticket granting ticket and the session key, now she's able to make a request of a service ticket by sending her ticket granting ticket back to the Kerberos authentication server. But at this time, the sub-element of Kerberos authentication server receiving Alice's ticket granting ticket is called ticket granting service. So ticket granting service is receiving Alice's ticket granting ticket, as you can see in this slide. So she's sending back this ticket granting ticket with her request. When Alice sends her ticket granting ticket and her request back to the Kerberos authentication server, note that her ticket granting ticket is not really encrypted by the session key because it's already encrypted, but her request is encrypted by Alice's session key just received from the Kerberos authentication server earlier. When Alice originally got her ticket granting ticket, it was encrypted with a secret key Kerberos authentication server created, and now note that the ticket granting ticket was actually encrypted by the authentication service of the Kerberos authentication server, which used a secret symmetric key to encrypt the ticket granting ticket, and that secret symmetric encryption key was also shared with the ticket granting service element of the Kerberos authentication server. So what happens is ticket granting service, since it has access to the secret key that was originally used to encrypt the ticket granting ticket, it can decrypt the ticket granting ticket, which contains a session key, which is the same as what Alice just received by the Kerberos authentication server. So what's going to happen is, from now on, for Alice to exchange information with the Kerberos authentication server, everything will be encrypted using the same session key, the one Alice has, and then also the one retrieved from the ticket granting service. So what happens next is the ticket granting service is now sending back a service ticket with another session key. At this time, the session key is also going to be encrypted by the original session key Alice was using, and also which is the same that was retrieved by the ticket granting ticket. So when the session key is sent back to Alice, it is encrypted, and a service ticket that's going to be used to get a service from a network resource you see here is not encrypted. Now the next step is, since now Alice has her service ticket, she can send it to the network resource she wants to use. So that's what's happening here in the next step. She's sending her service ticket back to the network resource, and the service ticket itself is again encrypted by, in this case, a secret key shared between this ticket granting service and this network resource. So ticket granting service and network resource are sharing this secret key. So what happens then is, since the network resource knows this secret key which was used to encrypt the service ticket, it is able to decrypt the service ticket. And the service ticket is now sent again with another session key. Since Alice already received a session key which is identical to what was stored in the service ticket, and the network resource is now able to decrypt the service ticket and then retrieve the session key, the same session key from the service ticket, the network resource can use the same encryption key to either encrypt or decrypt. So what happens is, if Alice sends something, the network resource is able to decrypt that information. And that's how the network resource knows whether Alice is a legitimate user or not, because the only person who should have that secret key is Alice. Nobody else should have received that secret key. So what happens is, when network resource is starting to communicate with Alice, it will be using the same secret key, the same session key Alice received originally, so that Alice is the only one who can decrypt it, and that's how Alice is able to use the network resource. So as you can see, the service is going back to Alice. However, everything in between Alice and the network resource will be encrypted using the session key Alice originally received from the ticket granting service. And then, as I mentioned, note that the ticket granting service and the network resource, they share a secret key used to both encrypt and unencrypt the service ticket, and that's how the network resource is able to decrypt the service ticket and knows what kind of service Alice is requesting. And since Alice has the same symmetric key, the network resource now knows Alice is a legitimate user. And that's how Kerberos works in general. In addition to the advantages we discussed when we were talking about Kerberos as a single sign-on system, Kerberos has its own disadvantages too. So for example, Kerberos has a single point of failure, in this case either key distribution center or Kerberos authentication server. Kerberos authentication server is what we actually looked at in our example, but in general that Kerberos authentication service is also called key distribution center, so they're used pretty much synonymously. And in our scenario, if Kerberos authentication server fails, nothing will work, so it has a very serious weakness right there. And then Kerberos has a very strict time requirement in terms of synchronization, because when the clocks on these different devices in the network where Kerberos is used are not in sync, the Kerberos system won't work, because synchronization is key to especially service tickets working properly. Because, for example, if you just got a service ticket which has a 5-minute expiration time, and the clock on a network resource to be used by a subject with that service ticket is 5 minutes ahead, before even you can try to use that resource, the ticket is already expired. So as you can see, synchronization in Kerberos environments is critical. So typically these clocks, at most, they cannot be out of sync more than 5 minutes.